to do combustion analysis for the test on Friday. Okay, so that comes for a resource.
Actually, I'll come tomorrow because half my resources.
Yeah, some of my freshmen know how to buy bus tickets, and only a few are going to be gone.
John,
You really think
He wouldn't know how to manage that. He would need like a chaperone. Like I would have to go with. Okay, today is Wednesday. I know. Today is Wednesday. Tomorrow is a work day. Kind of a lot going on. You have a test on Friday. The assessment that was in the basket today for organic is going to be due Monday. So can you write due Monday on it? Remember the one I put in the basket today, just in case you're not here tomorrow. The one that says assessment on it. It's going to be due Monday. There's no Form Bs on things that are take home, so your grade's going to be what it is on that one.
So I'll get 100 if I'm here in class tomorrow when we're doing it in class.
I think you have a better chance of getting 100 than if it weren't. I'll say.
So this assessment, is it like normal homework or is it like actually do?
Like actually do. Like
I need my notepads.
that's a legitimate question.
I never know. You said it's due Monday, but then we get to say it's like due a lot of days.
For like labs, it's just to manage my workload because I can't like grade every single day. But for like this is a test, so you gotta turn it.
Yeah, this is like
Take home test. Okay, we are here in our notes. Yesterday we learned how to name alkanes and alkynes, and I'm going to use highlighters again today. So if you want to grab,
hey, what colors?
I'm going to do my yellow and green again.
Are we like highlighting the same stuff?
Yeah.
Is that next quarter?
What?
Is the lab training today next quarter?
Yeah, because we need time to like do readings on it. Okay. If the substituent is a hydroxide, that is called an alcohol, and we add all to the name. So please make sure everyone around you is taking notes, like a big kid takes notes.
Where do I take notes here?
Okay, so
It's on your packet from yesterday. Oh my gosh.
remember, first step is to find the longest chain. Things that hang off the longest chain are called substituents. If our substituent is a hydroxide, we call it an all, it's an alcohol. We count our carbons so that our substituent numbers are lowest, but details in that today. Yesterday we only did carbons as substituents. Today we're adding alcohols, halogens, and including ring structures and double bonds. There's a hierarchy to numbering those. You want to make sure that if you have a combination of stuff that your hydroxide has the lowest number possible. So you know how it was like to make the lowest number? Now add a layer to make sure your hydroxide is lowest compared to everything else. So I'll show you an example of that. So this is a 1, 4 is a butane. All means that our substituent at carbon 1 is alcohol, which is a hydroxide. 1 butanol. So chlorines, bromines, and iodines can also be substituents. Those are called halogens, which is why they're called alkyl, like alkenes, halides, like halogens. If a substituent is a chlorine, we call that chloro. If it is a bromine, we call that bromo. And if it's an iodine, we call that iodo. Kind of fun. So same as always, find your longest chain. Look for your substituents. Now we got to really start paying attention to the alphabet as well. Things need to go in alphabetical order, not including prefixes. So when I'm counting, if I counted forward, I would have a 1, 2, 3, 3, 4. Or I would have a 1, 2, 2, 3, 3, 4. So a 2, 2, 3 is smaller than a 2, 3, 3. So I'm going to count backward.
I'm so confused.
here. Just let them go. Alphabetical order, bromine comes before chlorine, so I'm going to start with my 2-bromo. Then I have my 2,3 di, because they're twins, chloro. Alphabetical order, not including dis, tris, tetras. And then my longest chain is a butane. The amines we are going to say for later. All weak bases are amines, so we have a whole unit on them. We're not going to worry about them at this moment. When music starts, talk to somebody next to you about those two things. Ready, go. Organic compounds can also form ring structures. Ring structures just mean instead of being in a long chain, they fold in on themselves. It works the same way though. These corners are still carbons, just like if we did it with a line structure. And what we do is we just add cyclo in front of the name. So a 4-carbon is a butane. Because it's a ring structure, it goes in a circle, it's just a cyclobutane. So this one would be a cyclopentane. And what would this one be?
Octane.
Nope. There's 6.
There's 7.
Nope.
Wait, is that all one word or?
Yeah.
Yeah.
It doesn't.
I didn't even read it. I just guessed it.
Okay.
I'm aware.
If we have a ring structure, now numbering isn't going to go left to right, up and down. Now you can pick anywhere to start. So you need to number them to give the smallest number of substituents like normal. You're probably going to have to break some ties. Bigger are given the smaller number. Hydroxides win. Hydroxides go first. Okay? So for this example, your ring is always going to be considered your chain, no matter what. So anything hanging off of it is going to be considered a substituent.
Is that graded yellow?
When I number, I have to start at my biggest. Make your biggest, including hydroxide being the biggest, at number 1. So I'm going to call this 1. Now I can go clockwise, 1, 2, 3, 4, 5, or counterclockwise would give me the smaller numbers. So this would be a 1, 2. They are twins. The substituents are methyls. And what is it? It's a cyclopentane. So that is a 2,3-dimethyl cyclopentane. The thing about these ring structures is they often have a lot going on. In some of your work problems today, they're going to have double bonds, and they're going to have hydroxides, and they're going to have a substituent that has a substituent on it. So things can get big and complicated. Yes?
What if you pick the bigger one?
So these are the same, so it doesn't matter, but if this was an ethyl, it would have to be number 1. If this was a hydroxide here, it has to be number 1. Okay? Sometimes we have a special case. When you have a cyclohexane with alternating double bonds, it's very common, so it gets its own name. It is called benzene. You are not going to name it 1,3,5 cyclohextriene. You're going to call it benzene. Okay? And benzene is super common, so it also has some other names for it. So turn the page. Ortho, meta, and para. If it says ortho dichloro, for example, di means 2, chloro means chlorine, that means that the 2 chlorines are right next to each other. Ortho means they're right next to each other. Meta, di means 2, chloro, benzene means that there's a space in between. So on, off, on. Para, dichlorobenzene means that they are opposite of each other. They don't have to be up and down opposite. They can be this opposite or this opposite too. It just, as long as they're opposite, they're para. Okay? So I would like to get out your old worksheet. I'm gonna look at, so old, I mean from yesterday. I want to look at number 6 on the back.
You don't have that. Let's take that. Who thinks I have that? Who thinks I have that?
I gave it to you today. I should have just kept it. You need a basket like the babies have.
I cleaned it out before the
You cleaned that out?
There's so much less stuff.
Okay, let's look at 6. So I feel like this would be difficult to highlight, so I'm just going to use yellow. This is your chain. Your cyclo is always going to be your chain. These bonk, 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 and bonk, bonk are your substituents. Okay? When you number things that trump carbons, hydroxides, double bonds, and the halogens will trump it. So the rule is you need to go biggest, make smallest, but we need to count this double bond as our biggest. Okay, so I'm going to start here because a double bond is after it. Just kidding, I just did it backward. I'm going to start here because a double bond is after it, so double bond on 1. So I just made my double bond 1 because I'm going to make this 2, my propyl 3, nothing 4, and my ethyl 5. Now, how do I know this is an ethyl? Because it's a bonk bonk. 2 carbons is an ethyl. Bonk bonk bonk. 3 carbons is a propyl. Propyl is bigger. So alphabetical order though. 5 ethyl. 3 propyl. 1 cyclo. Pent, ene, because it's a double bond. Let's just pretend for 1 second that if there was 2 double bonds, let me show you how to do 2 double bonds. So let's put like another double bond there just for pretend. So after 3, what we would do is we'd say 1, 3 cyclopent diene. Because twins. You gotta squish it in down there. Okay? Now get out your new worksheet that I gave you today, this one. I have to show you some like editing things that is confusing.
This is how
It has lots of words on it. Okay, there are like 2 free programs to make organic compounds. The one that's easier to make them, which is what I use to make your assessment, is the same one they used here, but this is weird, so let me show you. In this program, it shows these terminal carbons. Terminal just means end, but it doesn't show the middle carbon. So this is a carbon, this is a carbon, this is a carbon, this is a carbon, and this is a carbon. This is a substituent stick. This is just like the branch to show the substituent. So this CH3 is this dot. And I don't know why it does that, but it's going to show up no matter what you Google just because it's like only one of 2 free ones to use. Okay, so if we were going to name this 1, 2, 3, 4, 5. I did start at the OH. Our longest chain has to be carbon. Okay, but now let's dot some other things. 1, 2, 3, 4, 5. All right, do you see like it says some C's but not all the C's? 1, 2, 3, 4, 5. Substituent methyl hydroxide. This is a methyl substituent. Okay. 1, 2, 3, 4, 5. 2 methyl 3 pentanol. Do you know why? It's because it doesn't matter whether you count backward or forward, the hydroxide is always going to be a 3. The answers were on all of them. Because I have no attention to detail, I just forgot to write that one out. Okay? Let this here. Look at this. Here is your main ring. Here is your substituent. It's a bonk, 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 but it has its own substituent. It has a methyl hanging off a propyl. This is called, it has a special name, and you wouldn't know this, nor do you need to know it. This is called an isobutyl. An isobutyl is a methyl propyl, meaning there's just a methane hanging off a propane. I Googled organic chem worksheet and this had good explanations, and I'm like, oh, this would be a good one. So, that's what happened. What I would like you to do today is, with a person, do not do this by yourself, please go through this new worksheet. Go through and try to name them. You'll probably finish before the hour's over if you kind of get it.
Dude, I get this on like week 7. I don't want anyone.